Hey folks, and welcome to today's video. Today we're going to be going over a multitude of pages. We have a roundup of Herrerasauridae and all of its currently known species. It's going to be interesting. I'm hoping that this video length will become the norm from now on, around 1.5 hours. With that, enjoy the video. Herrerasauridae. Herrerasauridae is a family of carnivorous basal saurischian dinosaurs. They are among the oldest known dinosaurs, first appearing in fossil record around 233.23 million years ago in the late Triassic, before becoming extinct by the end of the Triassic period. Herrerasaurids were relatively small-sized dinosaurs, no more than 4 meters or 13 feet long. Although a holotype specimen of Herrerasaurus Pvl, nowadays considered a synonym of Herrerasaurus Pvl, is thought to have reached around 6 meters or 20 feet long. The best known representatives of this group are from South America, particularly Brazil and Argentina, where they were first discovered in the 1930s in relation to Storicosaurus, and 1960s in relation to Herrerasaurus. A nearly complete skeleton of Herrerasaurus Pvl was discovered in the Igualasto Formation in San Juan, Argentina in 1988. These complete possible Herrerasaurids have been found in North America, and they may have inhabited other continents as well. Herrerasaurid anatomy is unusual and specialized, and they are not considered to be ancestral to any later dinosaur group. They only superficially resemble theropods and often present a mixture of very primitive and derived traits. The acetabulum is only partly open, and there are only 2 sacral vertebrae, the lowest number among dinosaurs. The pubic bone has a derived structure, being rotated somewhat posteriorly and folded to create a superficially developer-like terminal expansion, especially prominent in H. equidens. The hand is primitive in having 5 metacarpals and the third finger longer than the second, but resembles those of theropods in having only 3 fingers with curved claws. Herrerasaurids also have a hinged mandible, which is also found in theropods. It is not clear where Herrerasaurids lie on the early dinosaur evolutionary tree. They are possibly basal theropods or basal saurischians, but may predate the saurischian ornithischian split. Early researchers even proposed that they represented an early lineage of Sauropoda morphs. Some analyses, such as Nesbitt et al. 2009, have found Herrerasaurus and its relatives in Herrerasauridae to be very basal theropods, while others, such as Akora 2010, have found them to be basal to the clade Eusauriscia, that is, closer to the base of the saurischian tree than other theropods or Sauropoda morphs, but not true members of either. The situation is further complicated by the uncertainties in correlating the ages of late Triassic beds bearing land animals. Other proposed members of the clade have included San Monsaurus from the Igualasto Formation of Argentina, Storicosaurus, and Gnathovorax from the Santa Maria Formation in southern Brazil, Demonosaurus from the Petrified Forest, Chimney Formation of Arizona, and possibly Casiosaurus of the Doken Formation of Texas. Although the relationships of the North American animals are not fully understood, and not all paleontologists agree. Gregor Nijvitsky, I think I got that right. Stephen L. Brosset et al. 2014 described a European putative member of the group on the basis of Northern Age fossils discovered in Poland. Other possible basal saurischians include L. walkeria from the late Triassic Mallory Formation of southern India, and Tayuwasu, recently considered a synonym of Storicosaurus, known from very fragmentary remains from the late Triassic of Brazil. The discovery of Herrerasaurus Pvl indicates that the family falls outside of the Theropoda and Sauropodomorpha in the cladistic analysis undertaken on the genus when it was described, but remains clearly within Saurischia as basal members of the order. Fernando Novas, 1992, defined Herrerasauridae as Herrerasaurus, Storicosaurus, and their most recent common ancestor. Paul Sereno, 1998, defined the group as the most inclusive clade, including H. ishigualastensis, but not Pasa domesticus. Langer, 2004, provided the first phylogenetic definition of a higher level taxon. Herrerasauria as Herrerasaurus, but not Liliensternus or Plateosaurus. According to current phylogenetic studies, all of these definitions describe the same clade. The first cladogram presented follows one proposed analysis by Novas et al. In May 2011. In this review, Herrerasaurus is found to be a basal saurischian, but not a theropod. The second cladogram is based on an analysis by Sus et al. In April 2011. This review classified Herrerasaurus as a basal theropod. A large phylogenetic analysis of early dinosaurs by Matthew Barron, David Norman, and Paul Barrett in 2017 found Herrerasauridae within the clade Saurischia as the sister group to Sauropodomorpha. This was the result of the removal of Theropoda from Saurischia and its placement next to Ornithischia within the newly created clade Ornithischiata. Barron and Williams, 2018, found Herrerasauria, including Thaltopus and Casiosaurus, outside Dinosauria. A similar result was provided by the phylogenetic analysis by Cow in 2018. Tawa, named after the Hopi word for the Puebloan sun god, is a genus of theropod dinosaur from the late Triassic period. The fossil remains of Tawa, the type and only species were found in the Hayden Quarry of Ghost Ranch, New Mexico, US. Its discovery alongside the relatives of Coelophysis and Herrerasaurus supports the hypothesis that the earliest dinosaurs arose in Gondwana during the early late Triassic period in what is now South America, and radiated from there around the globe. The specific name honors Ruth Hall, founder of the Ghost Ranch Museum of Paleontology. Tawa was estimated to have been 2.5 meters, 8 foot 2 inches long as an adult, with a weight of 15 kilograms or 33 pounds. Tawa preserves characters that can be associated with different dinosaur taxa. Its skull morphology resembles that of Cephalopods, and the ilium approximates that of a Herrerasaurus. Like the Cephalopods, Tawa has a kink in its upper jaws between the maxilla and the premaxilla. With respect to its limb proportion, the femur is very long compared to the tibia. A neck vertebra adaptation in Tawa supports the hypothesis that cervical air sacs predate the origin of Neotheropoda and may be ancestral for saurischians, and also links the dinosaurs with the evolution of birds. Compared to earlier dinosaurs like Herrerasaurus and Eoraptor, Tawa had a relatively slender build. A diagnosis is a statement of the anatomical features of an organism or group that collectively distinguish it from all other organisms. Some, but not all, of the features in a diagnosis are also autapomorphies. An autapomorphy is a distinctive anatomical feature that is unique to a given organism or group. According to Nesbitt et al. 2009, Tawa can be distinguished based on the following features. The parotid bones meet on the ventral midline of the endocranial cavity. The anterior tympanic recess is greatly enlarged on the anterior surface of the basioccipital and extends onto the parotid and the parabasophoenoid. A deep recess is present on the posterior dorsal base of the paroccipital process, and a sharp ridge extending dorsoventrally on the middle of the posterior face of the basal tuber. An incomplete ligamental sulcus is present on the posterior side of the femoral head. A semicircular muscle scar or excavation is present on the posterior face of the femoral head. A small semicircular excavation on the posterior margin of medial posterior condyle of proximal tibia. A step is present on the ventral surface of the astragalus. Metatarsal 1 is similar in length to the other metatarsals. Fossils now attributed to Tawa were first discovered in 2004. The holotype, a juvenile individual catalogued GR241, consists of a mostly complete but disarticulated skull, forelimbs, a partial vertebral column, hind limbs, ribs, and gastralia. The determination was made that this specimen was a juvenile based on the presence of an open brain case and unfused neural central sutures. Fossils of at least 7 other individuals were also discovered at the site. One of these specimens, catalogued GR242, is also nearly complete. An isolated femur, GR244, suggests that adults were at least 30% larger than the juvenile holotype. GR242 was assigned as a paratype for the genus, along with specimens presenting a femora pelvis and a tail, GR155, and cervical vertebrae, GR243. All of these specimens are from the Hayden Quarry, a site in New Mexico which preserves many fossils of early dinosaurs and their close relatives. They were discovered in grey-green siltstone dating to the Norian stage of the Triassic period, approximately 215 to 213 million years ago. Tawa was formally described in 2009 by a group of 6 American researchers led by Sterling J. Nesbitt of the American Museum of Natural History. At the time of publication in the journal Science, Nesbitt was a postdoctoral researcher at the University of Texas at Austin's Jackson School of Geosciences. Based on the study of overlapping material of Dromaeron, Romeri, and Tawa, S. Christopher Bennett proposed that the two taxa were conspecific, forming a single growth series with D. Romeri being the juvenile and Tawa being the adult. However, noting prominent differences between the ephemera, which cannot be attributed to variation with age, Rodrigo Mueller rejected this proposal in 2017. He further noted that while D. Romeri is known from juveniles only, it shares many traits in common with D. gigas, which is known from mature specimens. The type species is Tawa hale, which was described in 2009 by Nesbitt et al. And considered more basal than Coelophysis, an early theropod from the late Triassic. In 2009, Mortimer cautioned that the analysis by Nesbitt et al. Was limited because it failed to consider all the characters of the relevant dinosaurs treated by the old analysis, e.g. Vibosaurus, Panophagia, Sinosaurus, Dracovanita, Nophostropheus, etc. Tawa was, however, to be found to be more advanced than the earlier theropod dinosaurs, Eoraptor, Herrerasaurus, and Storicosaurus. Sues et al. 2011 considered Tawa a derived early theropod. A cladistic analysis of Tawa and other early theropods indicate that the Coelophysoidea, a group of early dinosaurs, may be an artificial grouping because Tawa combines classic Coelophysoid features with features which appear to be ancestral to the Neotheropods. Tawa is believed to be the sister taxon of Neotheropoda, a group of carnivorous dinosaurs which largely bore only 3 functional digits on their feet. In 2011, Martinez and colleagues concluded that Tawa was the basal-most Coelophysoid, while a second 2011 analysis by paleontologists Martin D. Ezcura and Stephen L. Broussard, as well as a follow-up analysis modified with additional data by Yu Hai Lu and colleagues in 2014, found Tawa to be a primitive theropod. This position for Tawa was also recovered in the large analysis of early dinosaurs by Matthew Barron, David B. Norman, and Paul Barrett in 2017. The Hayden Quarry at Ghost Ranch belongs to the lower portion of the Petrified Forest member of the Chinle Formation in New Mexico. The discovery of Tawa alongside relatives of Coelophysis and Herrerasaurus supports the hypothesis that the earliest dinosaurs arose in Gondwana during the late Triassic period in what is now South America, and radiated around the globe from there. Ghost Ranch was located close to the equator 200 million years ago, and had a warm, monsoon-like climate with heavy seasonal precipitation. Hayden Quarry, an excavation site at Ghost Ranch, has yielded a diverse collection of fossil material that included the first evidence of dinosaurs and less advanced dinosauromorphs from the same time period. The discovery indicates that the two groups lived together during the early Triassic period, 235 million years ago. Tawa's paleoenvironment included various archosauriforms, such as crocodilomorphs, rossukians, phytosaurs, and dinosauriforms like Dromaeron, Tundosaurus, Eucoelophysis, and possibly Coelophysis. Based on their review of the early carnivorous dinosaur fauna from Ghost Ranch and the Eucoelophysis formation, Nesbitt et al. 2009 observed that each was descended from a separate lineage and inferred that the South American protocontinent Gondwana was the ancestral range for basal dinosaurs. Nesbitt et al. 2009 went on to note that dinosaurs left their ancestral range in Gondwana, and 200 million years ago they dispersed across the adjoining continents of Pangaea. Nesbitt et al. 2009 noticed that repeated flooding events collected vertebrate bones, carcasses, and plant material from the landscape surface, and possibly in hyper-concentrated flows, and deposited them at what is now Hayden Quarry. It was observed that these flooding events were separated by intervals where there was standing water and weakly developed, poorly drained hydromorphic soil formation. The Tawa specimens were very well preserved, which suggests they were buried extremely soon after dying. Demonosaurus is an extinct genus of possible theropod dinosaur from the late Triassic of New Mexico. Fossils have been found from deposits in the Chinle Formation, which is latest Triassic in age. While theropods had diversified into several specialized groups by this time, Demonosaurus is likely a very basal theropod, if one at all, and lies outside the clade near Theropoda. Demonosaurus is unusual among putative early theropods in that it had a short skull with long protruding teeth. Demonosaurus is known from a single fossil, the Holotype CM76821, which consists of a skull, mandibles, an atlas bone, an axis bone, other neck vertebrae, and rib fragments. This specimen was discovered in a sediment block collected from the Coelophysis quarry, also known as the Whitaker Quarry, at Ghost Ranch, New Mexico. This site is famous for abundant fossils of Coelophysis, an early theropod. See Tag 4, Tag 8.1. The block containing CM76821 was collected in the early 1980s by E.H. Colbert and is now housed in the collection of the Carnegie Museum of Natural History in Pittsburgh, Pennsylvania. Fossils of Coelophysis were also present in the block. CM76821 was first uncovered by a volunteer preparing the block while it was on loan to the State Museum of Pennsylvania in Harrisburg. Demonosaurus was named by Hans Dieter Seuss, Sterling J. Nesbitt, David S. Berman, and Amy C. Henlisi in the Journal Proceedings of the Royal Society B in 2011, and the type species is Demonosaurus julioides. The generic name Demonosaurus is derived from the Greek words daimon, meaning demon, and saurus, meaning reptile. The specific name is derived from the Greek word julioides, meaning prominent tooth, which is in reference to its procumbent front teeth. Based on the proportions of related theropods, Demonosaurus is estimated to have been around 1.5 meters, 5 feet long. Other estimates suggest that Demonosaurus was at most 2 meters or 7 feet long and weighed 22 kilograms or 49 pounds. The skull of Demonosaurus differs considerably from all other Triassic theropods. The snout is short and bears large premaxillary and maxillary teeth in the upper jaw. Procumbent teeth project forwards from the tips of the upper and lower jaws, which is highlighted in the species name Juliotus, that roughly means buck-toothed. Demonosaurus is unique among Triassic theropods because it has an unusually short snout, and all other early theropods had long heads and jaws. Like the coelophysoids, Demonosaurus has a kink in its upper jaws between the maxilla and the premaxilla. The proportionally large orbit, the short snout, and the apparent lack of fusion between the bones of the brain case suggests that the holotype specimen CM76821 may be an example of a juvenile dinosaur. On the other hand, the closure or fusion of the neurocentral sutures in the vertebrae suggest a mature individual. According to Seuss et al. 2011, Demonosaurus can be distinguished based on the following features. The skull is proportionally deep and narrow, with a short anterorbital region. The anterorbital fenestra nearly the same size as the external nares, a possible autapomorphy. The long posterior process of the premaxilla almost contacts the anterior process of the lacrimal bone, possible autapomorphy. The ventral process of the lacrimal bone has a slender posterior projection extending along anterodorsal margin of the jugal bone. The jugal is dorsoventrally deep and has prominent lateral ridges. The alveolar margin of the dentary is downturned at the symphysis. The postorbital with the anterolateral overhang over the orbit, and the prefrontal is large and occupies about 50% of the dorsal margin of the orbit. The first two dentary teeth are large and procumbent, and the premaxillary and anterior maxillary teeth are much enlarged relative to the posterior maxillary teeth. The third cervical vertebrae has a deep rimmed ovoid pleurocoels on the anterolateral surfaces of both the centrum and neural arch. Demonosaurus is typically considered to be a basal theropod that lies outside the clade Neotheropoda, a group which includes more advanced Triassic theropods like Coelophysis and their descendants. With such basal position, Demonosaurus represents a lineage that extended from the earliest radiation of dinosaurs in the Middle Triassic, alongside forms such as Eoraptor and Herrerasaurus from South America. A phylogenetic analysis conducted in its original description found Demonosaurus juliotus to be closely related to Tawahale, a theropod that was described in Ghost Ranch in 2009, and the Neotheropoda. Although the two theropods are closely related, Tawa was found at a quarry that is slightly older than the Whitaker quarry at Ghost Ranch. Seuss et al. 2011 noted that the discovery of Demonosaurus provided additional support for the theropod affinities of both Eoraptor and Herrerasauridae, and demonstrated that lineages from the initial radiation of Dinosauria persisted until the end of the Triassic. Examination of this genus by Seuss et al. 2011 demonstrates that Demonosaurus is separate and distinct from its other contemporaries. Demonosaurus differs from Herrerasaurus based on key features in the skull, and because it has much larger teeth in the premaxilla. Demonosaurus differs from Eodromaeus based on the features of the jawbone, skull, cheekbones, and because it has much larger teeth in the premaxilla. Demonosaurus differs from Eoraptorlunensis based on the presence of much larger premaxillary and anterior maxillary teeth, and a much more restricted antorbital fossa on the maxilla. Demonosaurus differs from Tawahale and Coelophysis bari in the features of the skull bones. Demonosaurus differs from Nichindosaurus bryan-smalley in features of the cervical vertebrae. A paper published by Barron et al. 2017 resurrected the clade Ornithoscelida to unite ornithischians and theropods to the exception of sauropodomorphs. Although not included in the original study, the authors added Demonosaurus to their dataset after their hypothesis was criticized by a team of international researchers, Langer et al. In 2017. In Barron et al.'s response, Demonosaurus was found to be the earliest ornithischian, retaining many theropod-like characteristics. Nesbitt and Sues 2020 rescored the genus and reran the analyses of both Langer et al. 2017 and Barron et al. 2017. Langer et al.'s analysis resulted in large phylotomy placing Demonosaurus is either a basal saurischian, a Herrerasaurid, or a basal salosaurid. When Agnosphytus, a fragmentary possible salosaurid, was removed from the analysis, Demonosaurus was placed as the sister taxon to Eusaurischia, which encompassed the theropod sauropodomorph split. The rescoring of Barron et al.'s analysis placed Demonosaurus as an ornithoskeleton outside the ornithischian theropod split. This area was also occupied by Tawa and Chindosaurus. Although Demonosaurus was not recovered as an ornithischian in any analysis, it also does not share any clear, unambiguous characteristics exclusively with theropods. Although Nesbitt and Sues 2020 consisted Demonosaurus a lightly saurischian, they were unable to conclusively place the genus within any subgroup of Dinosauria. Paleoenvironment. The only specimen of Demonosaurus was recovered at the Storicosaurus Whitaker Quarry at Ghost Ranch in the Rico Arriba County, New Mexico. This site preserves pebbly calcareous conglomerate rich in fossils of many different animals, with the theropod dinosaur Storicosaurus being particularly abundant. It has been correlated that the siltstone member of the Chinle Formation, which is tentatively dated to the Rhaetian or possibly latest Nourian stage of the late Triassic period. Ghost Ranch was located close to the equator 200 million years ago and had a warm, monsoon-like climate with heavy seasonal precipitation. The paleoenvironment of the Whitaker Quarry included a diverse collection of rhynchocephalians like Whitakersaurus, Archosauromorphs, and Archosaurs. Archosauriform taxa present include Phytosaurs, Redundosaurus, Crocodilomorphs, Hesperosaucus, Shuvosaurus, Ephigia, the Dinosauromorph Usilophysis, and the Dinosaur Silophysis. The multitude of specimens deposited so closely together at Ghost Ranch was probably the result of a flash flood event. Such flooding was commonplace during this period of Earth's history, and indeed, the nearby petrified forest of Arizona is the result of a preserved logjam of tree trunks that were caught on one such flood. In 1989, Colbert noted that the Demonosaurus specimen and several Silophysis specimens were washed into a small pond, where they drowned and were buried by a sheet flood event from a nearby river. Storicosaurus is a genus of Herrerasaurid dinosaur from the late Triassic of Brazil, found in the Santa Maria Formation. Colbert, 1970, describes Storicosaurus as a small and agile bipedal predator. Storicosaurus lived during the late Carnian and early Norian stage of the late Triassic, approximately 225 million years ago, which makes it one of the earliest dinosaurs known. At 2.25 meters, 7 feet 5 inches long, 80 centimeters or 31 inches tall, and weighing 30 kilograms or 66 pounds, Storicosaurus was small in comparison to later theropods like Megalosaurus. The type specimen has long but relatively slender limb bones. There exists a very incomplete fossil record of Storicosaurus, containing of most of the spine, the legs, and the large lower jaw. However, dating from such an early period in the dinosaur's history, and being otherwise so primitive, most of Storicosaurus' other features, as being primitive, can also be reconstructed. For example, Storicosaurus is usually depicted with 5 toes and 5 fingers, very simple features of an unspecialized dinosaur. However, since the skeletal structure of the legs is known, it can be seen that Storicosaurus was a quick runner for its size. It also had just 2 vertebrae joining the pelvis to the spine, a distinctly primitive condition. The available teeth for Storicosaurus bear a morphology that strongly suggests a carnivorous diet. The teeth are all serrated, laterally compressed, and caudally curved, i.e. the top of each tooth is curved backwards towards the throat. This dentition suggests that Storicosaurus could catch and hold prey, as well as slice and tear flesh to aid in mechanical digestion. The tail of Storicosaurus was relatively long, with more than 40 vertebrae compared to the rest of its body, and was held straight and off the ground as it ran. The rear part of Storicosaurus's tail is stiffened by features of the tail vertebrae. Ostrom, 1969, considered this adaptation to serve as a dynamic stabilizer, facilitating animal sleeping and running. A diagnosis is a statement of the anatomical features of an organism or group that collectively distinguish it from all other organisms. Some, but not all, of the features in a diagnosis are also autapomorphies. An autapomorphy is a distinctive anatomical feature that is unique to a given organism or group. According to Seuss, 1990, Storicosaurus can be distinguished based on the following 14 features. 1. A mandible almost as long as the femur, suggesting a proportionally large head. 2. A fairly deep but thin dentary with 13 to 14 teeth and a well-developed retroarticular process. 3. A vertebral column with 9 to 10 cervical, 15 dorsal, 2 sacral, and more than 40 caudal vertebrae. Storicosaurus is considered to be more primitive than any other dinosaur because only 2 sacral vertebrae are present. 4. An elongated third, fourth, and fifth cervical vertebrae, which represents a primitive condition. 5. Cranial cervical vertebrae that lacks epiphyses. Epiphyses. 6. The absence of accessory intervertebral articulations. 7. A slender scapular blade that is not expanded proximally. 8. A large and plate-like coracoid. 9. A humerus featuring a prominent deltopectoral crest represents a primitive condition, as well as having a distinctly expanded articular end. 10. An ilia with an extensively developed medial wall of a semi-perforate acetabulum, like Herrerasaurus, but unlike any other dinosaur. 11. A long pubis, 2/3 the length of the femur. 12. Hollow limb bones that feature fairly thick walls. 13. A robust femur with an S-shaped shaft. And 14. A tibia and fibula slightly longer than the femur. Nova, 1993, added that Storicosaurus is distinguished from other dinosaurs based on the presence of a distal bevel on the anterior margin of its pubis. Langer and Benton, 2006, noted that Storicosaurus can be distinguished based on the anterior trochanter being reduced to a scar. Bittencourt and Kellner, 2009, noted that the proximal fibula has a medial sulcus, which is unique to Storicosaurus Pvl. Storicosaurus means Southern Cross, after the star constellation visible from the southern hemisphere, and lizard from the Greek word saurus, meaning lizard. Thus, the Southern Cross lizard. The species name Pvl is in honor of Colbert's fellow paleontologist, Llewellyn Ivor Price. The first known specimen of Storicosaurus was recovered from the paleontological site Yazdigal Chinko of the Santa Maria Formation, Rio Grande do Sul, southern Brazil. Storicosaurus was found in mid-Carnian sediments. The genus name refers to the star constellation the Southern Cross, pictured in the coat of arms of Brazil, and only visible in the southern hemisphere, where Storicosaurus was described in 1970. It was unusual to find dinosaurs in the southern hemisphere. The specific name honors the Brazilian paleontologist Llewellyn Ivor Price, who discovered it in 1936. It was described by Edwin Harris Colbert, working at the American Museum of Natural History. The rarity of Storicosaurus remains may be a result of its being uncommon while alive, or because it lived in an environment like a forest, where fossils rarely form. Nonetheless, Garcia et al. 2019 referred the holotype of Theropoda barberinae as a second specimen of Storicosaurus Pvl. See class. Later research by Seuss et al. 2011 supports that Storicosaurus and the related genus Herrerasaurus are theropods and evolved after the sauropod line had split from Theropoda. Mortimer points out that Benedetto (1973) and Galton (1985) were the first to recognize that Storicosaurus and Herrerasaurus were more closely related to each other than to sauropodomorphs or apods, placing them both in the Herrerasauridae and Herrerasauria. Storicosaurus differs from Herrerasaurus because of its considerably smaller size, femur length of 23 cm or 9.1 inches versus the 47 cm or 19 inches. Serrano et al. 1993 concluded that Storicosaurus was not a theropod and considered it a basal saurischian outside Theropoda and Sauropodomorpha. Storicosaurus was originally incorrectly assigned by Colbert to Paleosauridae, a defunct family based largely on Euphrasia, a prosauropod dinosaur. All major phylogenetic analyses since 1994 have assigned Storicosaurus to the clade Herrerasauridae, which is the current scientific consensus on classification of this genus. Bittencourt and Kellner, 2009, stated that the phylogenetic position of Storicosaurus is constrained by its close relationship with Herrerasaurus eschegualastensis, which is more complete and well known. Storicosaurus was placed in the clade Herrerasauridae by Benedetto in 1973. Herrerasauridae also includes Herrerasaurus eschegualastensis and Eoraptor lunensis, both small predatory animals that were either dinosaurs or precursors to dinosaurs. These three dinosaurs lived during the Carnian stage of the Triassic period. Some phylogenetic analyses excluded Eoraptor from the Herrerasauridae. Phylogenetic analysis by Seuss, Nesbitt, Berman, and Henrici in 2011 exclude Eoraptor and include Gindosaurus along with Herrerasaurus as more derived than Storicosaurus. Monsaurus was assigned to Herrerasauridae by Alcoba and Martinez, 2010. Seuss, 1990, assigned Ichthyosaurus to Herrerasauridae. Other proposed members of the clade have included the San Juansaurus from the same Eschegualasto formation of Argentina as Herrerasaurus, and possibly Casiosaurus from the Dauphin formation of Texas, although the relationships of these animals are not fully understood, and not all paleontologists agree. Alcoba and Martinez, 2010, concluded that Storicosaurus and San Juansaurus are closely related based on similarities in their pubis and tibia. The controversial dinosauriform Teowasu barberoni was recently considered a synonym of Storicosaurus price. Both taxa are known from single, incomplete, and somewhat poorly preserved specimens. Therefore, the former holotype specimen of Teowasu would be the second specimen ascribed to a Storicosaurus within almost 50 years of its naming. The synonymy was based on a combination of 5 osteological features that are only present in both specimens among Triassic early dinosauriforms. 1. Femur without a trochanteric shelf. 2. Symmetric fourth trochanter of the femur. 3. Crista tibiofibularis poorly separated from the lateral condyle at the distal end of the femur. 4. Posterolateral flange of the distal end of the tibia does not exceed the lateral margin of the bone. 5. And rounded distal end of the tibia. Storicosaurus was a small but active bipedal predator that preyed on small and medium-sized terrestrial vertebrates such as cynodonts, rhynchosaurs, and herbivorous synapsids. The mandible of Storicosaurus suggests that a sliding joint in the jaw allowed it to move backwards and forwards as well as up and down. However, some authors question the presence of an intramandibular joint in Storicosaurus due to the poor preservation of the holotype. Smaller prey could be worked backwards towards Storicosaurus' throat, aided along by its small backwards curving teeth. This feature was common in theropods of its time, but would disappear in later theropods. During the late Triassic, dinosaurs played only a minor role in terrestrial life, a fact that would change by the early Jurassic. Storicosaurus coexisted with large Rauisuchian archosaurs like Saurosuchus, which were the top carnivores in their ecosystems. Storicosaurus' paleocommunity included medium to large herbivorous rhynchosaurs and dicynodonts, medium-sized omnivorous aetosaurs, and cynodonts were also present. Dinosaurs were represented by the Herrerasauridae, which includes Storicosaurus, and the basal sauropodomorph Saturnalia. The contemporaneous occurrence of basal theropods Storicosaurus, Herrerasaurus, and Eoraptor with the ornithischian Pisanosaurus suggests that the main carnivorous and herbivorous lineages were established during the middle part of the Carnian stage. A uranium-led uranium decay dating site found at the Santa Maria Formation dated around 233.23 million years ago, putting it 1.5 million years older than the Ischigualasto Formation, and making the two formations approximately equal as the earliest dinosaur localities. Herrerasaurus. Herrerasaurus was a genus of Saurischian dinosaur from the late Triassic period. This genus was one of the earliest dinosaurs from the fossil record. Its name means Herrera's lizard, after the rancher who discovered the first specimen in 1958 in South America. All known fossils of this carnivore have been discovered in the Ischigualasto Formation of Carnian age, late Triassic according to the ICS, dated to 231.4 million years ago in northwestern Argentina. The species type Herrerasaurus ischigualastensis was described by Osvaldo Reich in 1963 and is the only species assigned to the genus. Ichthyosaurus and Thrunguelisaurus are synonyms. For many years, the classification of Herrerasaurus was unclear because it was known from very fragmentary remains. It was hypothesized to be a basal theropod, a basal sauropodomorph, a basal saurischian, or not a dinosaur at all, but another type of archosaur. However, with the discovery of an almost complete skeleton and a skull in 1988. Herrerasaurus has been classified as either an early theropod or an early saurischian in at least 5 recent reviews of theropod evolution, with many researchers treating it at least tentatively as the most primitive member of Theropoda. It is a member of the Herrerasauridae, a family of similar genera that were among the earliest of dinosaurian evolutionary radiation. Herrerasaurus was named by paleontologist Osvaldo Reich after Victorino Herrera, an Andean goat herd who first noticed the fossils and outcrops near the city of San Juan, Argentina in 1959. These rocks, which later yielded Eoraptor, are part of the Ishigualasto Formation and date from the late Landinian to the early Carnian stages of the late Triassic period. Reich named a second dinosaur from these rocks in the same publication as Herrerasaurus. This dinosaur, Ischisaurus catoi, is now considered a junior synonym and a juvenile of Herrerasaurus. Reich believed Herrerasaurus was an early example of a carnosaur, but this was the subject of much debate over the next 30 years, and the genus was variously described during that time. And the genus was variously classified during that time. In 1970, Steele classified Herrerasaurus as a prosauropod. In 1972, Peter Goulden classified the genus as not diagnosable beyond Sauriskia. Later, using cladistic analysis, some researchers put Herrerasaurus and Storicosaurus at the base of the dinosaur tree before the separation between ornithischians and saurischians. Several researchers classified the remains as non-dinosaurian. 2 other partial skeletons with skull material were named Fringuellosaurus and Ishigualastensis by Fernando Novas in 1986, but this species too is now thought to be a synonym. Fringuellosaurus ishigualastensis was discovered in 1975 and was described by Novas 1986, who considers it a primitive saurischian and possibly a theropod. Novas 1992 and Serrano and Novas 1992 examined the Fringuellosaurus remains and found them referable to Herrerasaurus. Ischisaurus catoi was discovered in 1960 and described by Reich in 1963. Novas 1992 and Serrano and Novas 1992 reviewed its remains and found to be referable to Herrerasaurus. A complete Herrerasaurus skull was found in 1988 by a team of paleontologists led by Paul Serrano. Based on the new fossils, authors such as Thomas Holtz and Jose Bonaparte classified Herrerasaurus at the base of the Saurischian tree before the divergence between prosauropods and theropods. However, Serrano favored classifying Herrerasaurus and the Herrerasauridae as primitive theropods. These 2 classifications have become the most persistent, with Rahult 2003 and Bittencourt and Kellner 2004 favoring the early theropod hypothesis, and Max Langer 2004, Langer and Brenton 2006, and Rendell Ermis and his co-authors 2007 favoring the basal saurischian hypothesis. If Herrerasaurus were indeed a theropod, it would indicate that theropods, pseudopodomorphs, and ornithischians diverged even earlier than Herrerasaurids, before the Middle Cardian, and that all three lineages independently evolved several dinosaurian features, such as more advanced angle joints or an open acetabulum. This view is further supported by ethnological records showing large tridactyl three-toed footprints that can be attributed only to a theropod dinosaur. These footprints date from the Lindenian Middle Triassic of the Los Rastros Formation in Argentina and predate Herrerasaurus by 3 to 5 million years. The study of early dinosaurs such as Herrerasaurus and Eoraptor, therefore, has important implications for the concept of dinosaurs as a monophyletic group, a group descended from a common ancestor. The monophyly of dinosaurs was explicitly proposed in the 1970s by Galton and Robert T. Bakker, who compiled a list of cranial and postcranial synapomorphies, common anatomical traits derived from the common ancestor. Later authors proposed additional synapomorphies. An extensive study of Herrerasaurus by Serrano in 1992 suggested that of these proposed synapomorphies, only one cranial and 7 postcranial features were actually described from a common ancestor, and that the others were attributable to convergent evolution. Serrano's analysis of Herrerasaurus also led him to propose several new dinosaurian synapomorphies. Herrerasaurus was a lightly built bipedal carnivore with a long tail and relatively small head. Adults had skulls up to 56 centimeters, 22 inches long, and were up to 6 meters, or 20 feet in total length, and 350 kilograms, or 770 pounds, in weight. Smaller specimens were half that size, with skulls only about 30 centimeters, or 12 inches long. Herrerasaurus was fully bipedal. It had strong hind limbs with short thighs and rather long feet, indicating it was likely a swift runner. The foot had 5 toes, but only the middle 3, digits 2, 3, and 4, bore weight. The outer toes, 1 and 5, were small. The first toe had a small claw. The tail, partially stiffened by overlapping vertebral projections, balanced the body and was also an adaptation for speed. The forelimbs of Herrerasaurus were less than half the length of its hind limbs. The upper arm and forearms were rather short, while the manus hand was elongated. The first 2 fingers and the thumb ended in curved, sharp claws for grasping prey. The 4th and 5th digits were small stubs without claws. Herrerasaurus displays traits that are found in different groups of dinosaurs, and several traits found in non-dinosaurian archosaurs. Although it shares most of the characteristics of dinosaurs, there are a few differences, particularly in the shape of the hip and leg bones. Its pelvis is like that of Saurischian dinosaurs, but it has a bony acetabulum where the femur meets the pelvis that was only partially open. The ilium, the main hip bone, is supported by only 2 sacrals, a basal trait. However, the pubis points backwards, a derived trait as seen in dromaeosaurids and birds. Additionally, the end of the pubis had a booted shape, like those in theropods, and the vertebral centra has an hourglass shape as found in Allosaurus. Herrerasaurus had a long, narrow skull that lacked nearly all the specializations that characterized later dinosaurs, and more closely resembled those of more primitive archosaurs, such as Eupacaria. It had 5 pairs of fenestrae, skull openings in its skull, 2 pairs of which were for the eyes and nostrils. Between the eyes and the nostrils were 2 antorbital fenestrae, and a pair of tiny 1 centimeter long, 0.39 inches, slit-like holes called promaxillary fenestrae. Herrerasaurus had a flexible joint in the lower jaw that could slide back and forth to deliver a grasping bite. This cranial specialization is unusual among dinosaurs, but has evolved independently in some lizards. The rear of the lower jaw also had fenestrae. The jaws were equipped with large serrated teeth for biting and eating flesh, and the neck was slender and flexible. According to Novus 1993, Herrerasaurus can be distinguished based on the following features: the presence of premaxillar maxillar fenestra in the dorsal part of laterotemporal fenestra is less than a third as wide as the ventral part, the presence of a ridge on the lateral surface of the jugal bone, and a deeply incised supratemporal fossa that extends across the medial postorbital process. The subquadrate ventral squamosal process has a lateral depression, and the quadrato-jugal bone overlaps the posterior-dorsal quadrate face. The pterygoid process of the quadrate has an interned trough-shaped ventral margin, and the presence of a slender ribbed posterior-dorsal dentary process. The surangular bone has a forked anterior process for articulation, with a posterior-dorsal dentary process. The humerus internal tuberosity is proximally projected and separated from the humeral head by a deep groove, also present in coelophysoids. Possess enlarged hands, which is 60% of the size of the humerus in radius, and the humeral antipocondyle is ridge-like with anterior and posterior depressions, and the posterior border of the iliopendicle forms a right angle with the dorsal border of the shaft on the ischium. According to Serrano, 1993, Herrerasaurus can be distinguished based on the following features, all of which are unknown in other Herrerasaurids. A circular pit is present on the humeral epicondyle, a feature also present in Saturnalia, a saddle-shaped ulnar condyle of the humerus, and the articular surface for the ulnari on the ulna is convex. The articular surface of the ulnari is similar than that of the ulna, a feature unknown in Storicosaurus and Monsaurus. The centrile is placed distal to the radial, a broad subnarial process of the premaxilla, and a broad supratemporal depression noted by Serrano and Novus and Novus 1993. The basal tuber and occipital condyle are subequal in width, noted by Serrano and Novus 1993. Herrerasaurus was originally considered to be a genus within Carnosauria, which then included forms similar to Megalosaurus and Antrodomus. The latter is equivalent to Allosaurus, even though Herrerasaurus lived many millions of years before them and retained multiple primitive features. This Carnosaurian classification was amended upon by Rojdestvensky and Tatarinov in 1964, who classified Herrerasaurus within the family Cryponidae, and Cycanosauria. The same year, Walker published a differing opinion that Herrerasaurus was instead allied with the Plateosauridae, although it differed in possessing a pubic boot. Walker also proposed that Herrerasaurus may instead be close to Papasaurus, now considered a pseudosuchian, and the unnamed theropod from the token group of Texas, now assigned to the Roasuchian Postosuchus. In 1985, Charab noted that Herrerasaurus was of uncertain classification, showing similarities to both prosauropods and carnosaurians. Roma, in 1966, simply noted that Herrerasaurus was a prosauropod, possibly within the Plateosauridae. In the description of Storicosaurus, Colbert noted that there were many similarities between his taxon and Herrerasaurus, but classified them in separate families, with Herrerasaurus and Teratosauridae. In 1970, Bonaparte also proposed similarities between Herrerasauridae and Herrerasaurus and Storicosaurus, while classifying them both clearly as Ansauriscia. He stated that they appeared as though they could not be placed in their current family. This was further supported by Benedetto in 1973, who named for the taxa and the new family Herrerasauridae, which he classified as Saurischians, possibly within Theropoda, but not in Sauropodomorpha. However, in 1977, Galton proposed that Herrerasauridae only included Herrerasaurus, and found it to be Saurischian in Cetacetus. Proposed in 1987 by Brinkman and Seuss, Herrerasaurus has at times been considered basal to Ornithischia and Saurischian, although Brinkman and Seuss still consider it to be inside Dinosauria. They supported this on the basis that Herrerasaurus has a large pedal digit 5 and has a well-developed medial wall on the acetabulum. Brinkman and Seuss consider Storicosaurus and Herrerasaurus to not form a true group called Herrerasauridae, and that instead they were successively more primitive forms. Also, they considered the characters used by Benedetto to be invalid, instead representing only the plesiomorphes state that was found in both taxa. This was disagreed with in 1992 by Novus, who stated many derived synapomorphies of the Herrerasauridae, such as a distinct pubic boot, but still classified them as bases to Ornithischia and Saurischian. Novus defined the family as the least common ancestor of Herrerasaurus and Storicosaurus, and all of its descendants. A differing definition of Herrerasaurus but not Pasa domesticus, first suggested by Serrano, 1998, and more closely follows the original inclusion proposed by Benedetto. Another group, Herrerasauria, was named by Galton in 1985 and defined as Herrerasaurus but not as Liliensternus or Plateosaurus by Langer, 2004, who used the node-based definition for Herrerasauridae. So much argument about this dinosaur. My goodness. In a revision of Basal Dinosauria, Padian in May 1993 discussed the definition of the clade and redefined it as the latest common ancestor of Triceratops and birds. They also discussed what this definition would do to the most basal taxa such as Herrerasauridae and Eoraptor. Paddy and May considered that since both Herrerasauridae and Eiraptor lack many diagnostic features of Saurischia or Ornithischia, that they could not be considered inside Dinosauria. A later 1994 study by Novus instead classified Herrerasaurus within Dinosauria and strongly supported its decision within Saurischia, as well as provided anapomorphies that it shared with Theropoda. Novus found that the primitive features lacking the brevis fossa and having only two sacral vertebrae were simply reversals found in the genus. In 1996, Novus went further by supporting a theropod position for Herrerasaurus with a phylogenetic analysis which placed it closer to Neotheropoda than Eiraptor or Sauropodomorpha. Langer, 2004, mentioned that this hypothesis was widely accepted, but that more later authors instead preferred to place Herrerasaurus, as well as Eiraptor, basal to Theropoda, and Sauropodomorpha, a clade called Saurischia. Langer, 2004, conducted a phylogenetic analysis and found it was much more likely that Herrerasaurus was a basal Saurischian than either a theropod or a non-dinosaurian. Langer's proposal was supported by multiple studies until the discovery of Tawa, when Nesbitt et al. Conducted a more inclusive analysis, and the resulting cladogram placed Herrerasauridae basal to Eiraptor, but closer to Dilophosaurus than Sauropodomorpha. Unlike Nesbitt, Iscora, 2010, conducted a phylogenetic analysis to place his new taxon, Chromachisaurus, and found that Herrerasauridae was basal to Saurischia. In 2010, Alcocer and Martinez described a new taxon of Herrerasaurid, Monsaurus. It could be distinguished from Herrerasaurus based on multiple features. In the phylogenetic analysis, Herrerasaurus, Monsaurus, and Storicosaurus all were in a polytomy, and Herrerasauridae was the most primitive group of Saurischian, outside of Saurischia, Eiraptor, and Guaibasaurus. In 2011, Martinez et al. Described Eodromeus, a basal theropod from the same formation as Herrerasaurus. In a phylogenetic analysis, Eiraptor was placed within Sauropodomorpha. Herrerasauridae was placed as the most basal theropods, and Eodromeus was placed as the next most basal. A more recent analysis by Bittencourt et al. 2014 placed Herrerasauridae in a polytomy with Theropoda and Sauropodomorpha, with Eiraptor also being in an unresolved position. This cladogram is shown below. Oh, that's for an image. Sorry. Other members of the clade may include Eiraptor from the same Esquilasta formation of Argentina as Herrerasaurus, Chindosaurus from the Upper Petrified Forest, Chinle Formation of Arizona, and possibly Castiosaurus from the Secovus Formation of the Durham Group in Texas, although the relationships of these animals are not fully understood, and not all paleontologists agree. Other possible basal theropods, Albocaria from the late Triassic Lower Malari Formation of India, and Tayawasu, known from very fragmentary remains in the late Triassic of Brazil, might be related. Paul, 1988, noted that it had been incorrectly suggested that Storicosaurus Pvl was a juvenile Herrerasaurus. This claim was refuted when pelvic bones from a juvenile Herrerasaurus were discovered, which upon examination did not resemble the pelvic bones of Storicosaurus. The teeth of Herrerasaurus indicate that it was a carnivore. Its size indicates that it would have preyed upon small and medium-sized plant eaters. These might have included other dinosaurs, such as Monosaurus, as well as the more plentiful Rhynchosaurs and synapsids. Herrerasaurus itself may have been preyed upon by giant Rauasuchids like Saurosuchus. Puncture wounds were found in one skull. Coprolites, fossilized dung containing small bones, but no trace of plant fragments, discovered in the Esquilasta Formation, have been assigned to Herrerasaurus based on fossil abundance. Mineralogical and chemical analysis of these coprolites indicates that if the referral to Herrerasaurus were correct, this carnivore could digest bone. Comparisons between the scleral rings of Herrerasaurus and modern birds and reptiles suggest that it may have been cathmeral, active during the day at short intervals. In a 2001 study conducted by Bryce Rothschild and other paleontologists, 12 hand bones and 20 foot bones referred to Herrerasaurus were examined for signs of stress fractures, but none were found. PVSJ407, a Herrerasaurus equilistensis, had a pit and a skull bone attributed by Paul Sereno and Novus to a bite. 2 additional pits occurred on the splenial. The areas around these pits are swollen and porous, suggesting the wounds were afflicted by a short-lived, non-lethal infection. Because of the size and angles of the wound, it is likely that they were obtained in a fight with another Herrerasaurus. The holotype of Herrerasaurus Pvl 2566 was discovered in the Concha de Pochas member of the Esquilasta Formation in San Juan, Argentina. It was collected in 1961 by Victorino Herrera in sediments that were deposited in the Carnian state of the Triassic period, approximately 235 to 231 million years ago. Over the years, the Esquilasta Formation produced other fossils, ultimately referred to Herrerasaurus. In 1958, A.S. Roma discovered specimen MCZ7063, originally referred to Storicosaurus in Carnian sediments. Herrerasaurus specimens PVL 2045 and MLP 461 were collected in 1959 and 1960 respectively, in sediments that were deposited in the Nourian stage of the Triassic period, approximately 228 to 208 million years ago. In 1960, Scaglia collected specimen MACN 18.060, originally the holotype Eschisaurus catoi, and sediments deposited in the Carnian stage. In 1961, Scaglia collected Herrerasaurus specimen PVL 2558 in the Carnian beds of this formation. In 1990, the Concha de Pochas member produced more Herrerasaurus specimens, also from the Carnian beds. Specimen PVSJ53, originally the holotype of Frunqualisaurus, was collected by Garguilo and Oñate in 1975 sediments that were deposited in the Carnian stage. Although Herrerasaurus shared the body shape of large carnivorous dinosaurs, it lived during a time when dinosaurs were small and insignificant. It was a time of non-dinosaurian reptiles, not dinosaurs, and a major turning point in the Earth's ecology. The vertebrate fauna of the Ischigualasto Formation, slightly later Los Colorados Formation, consisted mainly of a variety of cruritarsal archosaurs and synapsids. In the Ischigualasto Formation, dinosaurs constituted only about 6% of the total number of fossils, but by the end of the Triassic period, dinosaurs were becoming the dominant large land animals, and other archosaurs and synapsids declined in variety and number. Studies suggest that the paleoenvironment of the Ischigualasto Formation was a volcanically active floodplain, covered in by forests and subject to strong seasonal rainfall. The climate was moist and warm, though subject to seasonal variations. Vegetation consisted of ferns, cladophlebas, horsetails, and giant conifers, Protogeniperoxylum. These plants formed lowland forests along the banks of rivers. Herrerasaurus remains appear to have been the most common among the carnivores of the Ischigualasto Formation. It lived in the jungles of late Triassic South America alongside another early dinosaur, the 1 meter long Eoraptor, as well as Saurosuchus, a giant land-living Rauisuchian, a quadrupedal meat-eater with a theropod-like skull. The broadly similar but smaller Venaticosuchus and Ornithosuchid, and the predatory therospid Geniquodontids. Herbivores were much more abundant than carnivores and were represented by rhynchosaurs as Hyperodapedon, a big reptile, Aetosaurs, spiny armored reptiles, and therapsids, including Camairid dicynodonts, stocky front heavy-beaked quadrupedal animals, such as Ischigualistia and transversodontid cynodonts, somewhat similar in overall form to dicynodonts, but lacking beaks, such as Ixaritodon. San Juansaurus is a genus of Herrerasaur dinosaur from the late Triassic, Carnian, Conchatabolchus, and Larpania members of the Ischigualasto Formation of the Ischigualasto via Union Basin in northwestern Argentina. San Juansaurus was comparable in size to a medium-sized Herrerasaurus, with a thigh bone that was 395 millimeters, 15.6 inches long, and a tibia that is 260 millimeters, 10 inches in length. Alcoba and Martinez performed a phylogenetic analysis and found that San Juansaurus to be a Herrerasaurid. It was determined that San Juansaurus and Herrerasaurus share many similarities in the morphology of the skull, neck vertebrae, back vertebrae, hip vertebrae, scapula, and the hip bones. Alcoba and Martinez observed that San Juansaurus and Storicosaurus share many similarities in the morphology of the hip bones and the tibia. The pubis of Monsaurus, unlike in other Herrerasaurids, points towards the cranium. Distinguishing anatomical features. A diagnosis is a statement of the anatomical features of an organism or group that collectively distinguish it from all other organisms. Some, but not all of the features in a diagnosis are also autapomorphies. An autapomorphy is a distinctive anatomical feature that is unique to a given organism or group. According to Alcoba and Martinez, 2010, Monsaurus can be distinguished based on the following characteristics. The cervical vertebrae have shelf-like, posterolaterally directed transverse processes. The neural spines of the 6 to 8 dorsal vertebrae, at least, bear acute anterior and posterior processes. The glenoid has everted lateral margins. The pubis is relatively short, measuring 63% of the length of the femur. A pronounced rugose scar is present on the medial surface of the femur at the level of the 4th trochanter. Monsaurus was named and described in 2010 by Oscar Alcoba and Ricardo Martinez. The type species was named S. gutioi after Raul Gutio, the head fossil preparator and artist of the San Juan Museum. It is known from and based on an associated and partially articulated partial skeleton, PVSJ605, consisting of a jaw fragment, most of the vertebral column from the axis to the anterior tail, the shoulder blades and ulna, part of the pelvis, most of the long bones of the legs, and a few other bones. Monsaurus, holotype specimen PVSJ605, was discovered in 1994 in grey-green sandstone at the Cancha de Bocas member near the base of the Esquilasto Formation in the Esquilasto Provincial Park in San Juan, Argentina. This horizon dates to approximately 231.4 million years ago, during the late Carnian stage of the late Triassic. The Esquilasto Formation dinosaurs constituted only about 6% of the total number of fossils, but by the end of the Triassic period, dinosaurs were becoming the dominant large land animals, and other archosaurs and synapses declined in variety and number. Studies suggest that the paleoenvironment of the Esquilasto Formation was of... I've actually read this before. It's repeated twice in the wiki. Interesting. Well, that is all for today. So I really hope you enjoyed listening today. It was a long one and a little tough to get through, but we got there in the end. I hope to keep going with ones about this long, but we'll see how long my voice holds out. Anyways, I hope you all have a beautiful day and take care of yourselves.